Okay, so now let's think a few other stuffs to understand better. Okay, because when it comes about substation, we need to have many other understanding. Uh, what is generation? What is transmission? What is distribution? So let's try to understand few steps so that we can see in a larger view. Okay, so this is what we are going to discuss quickly, right? So in a electrical part, actually we can uh, categorize into three stuffs, three categories: generation, transmission, distribution, right? So basically, when we say generation means thermal, hydro, nuclear, wind, solar power. That is these areas that we are generating the power, right? So transmission, of course, whatever that we are generating, we are transmitting it through the transmission lines, right? So in India, we have, I think, beyond 765 also we have the voltage levels are there, right? And substation, this is where we transform, or we do the switching operation and controlling voltage at every level, right? Distribution also. But actually here we have put 11. In a real case, maybe distribution starts from 33 kV onwards. Okay, 33 kV onwards. Okay, uh, 33 kV to down till 415 till whatever that end equipment voltage, that is called distribution, right? So so basically generation happens. If you look at the major big generators which is available, maybe typically the generating voltage will be 11 kV or 15 kV, something like that. Very rare that generators are generating voltage at 33 kV, but yes, few big generators it is maybe slightly less than that we have actually. But most of the big capacity generators maybe uh, 12 or sorry 15 kV, something like that, only the generating voltage will be there. Then or 10.5 or something like that. So then they will step up. The step up happens again 110 or maybe in this range, any range it will be. Then further, because we cannot generate uh, like the generation is happens like that, but transmitting, because it is somewhere in the plant, in the remote it happens. So the transmitting from step up through the transmission lines, this is how it happens actually. So here only the high voltage comes into picture. Lot of substations comes in this category, right? Again, you have to step down. So whatever that high voltage, no, again you have to step down into distributable voltage, right? Because why we are stepping up, very well, loss. Loss is the major concern that we are bringing it, because in a fundamentally, what you need to understand is, see, there is a simple phenomenon. Anywhere when you are working with the electrical system, you have to consider two parameters majorly, very importantly. One is voltage, another one is current. Always you have to think. When you say current flows through the conductor. Okay, current flows through the conductor, because the moment current flows through the conductor, that means there will be your conductor should be able to handle such a current. So the current impacts the thermal capability of the conductor. It could be anything, any conductor. Okay, so or thermally or dynamically you have to think. So always short circuit, or when I say current, it is current, normal full load current or short circuit current. Or sometimes they call it as a over current. So over current can be categorized into two things. One is short circuit current or voltage short circuit. Second one is over current via overload. That means this overload current will be less than this only. Short circuit happens very fast. So maybe it will be there for 1 second, or maximum beyond maybe slightly on the higher side. But overload current maybe for it will be there forever or sometime. Then your relay should be able to detect and trip it. So when we say current, you have to see the conductor cross section. Always you have to see conductor, let's say that 300 square mm or 240 square mm, something like that. You have to see the conductor cross section. Why? Why? Because very simple reason, your R is equal to rho A by L. This is one formula that you have to remember always. And I squared R. So these formulas you have to remember. That's the loss. Because the more current, every conductor has a impedance. See, why I am putting R. Basically, when it comes about AC voltage, we are combining resistance and reactance, right? So that means it becomes an impedance, right? So basically, when you have this, the more because your impedance is directly proportional to the cross sectional area, right? So that means less impedance, or you can say that when the cross sectional current increases, your current increases, right? So you have to think like that. You have to correlate it. The more current, the current more means then because of this losses also more. So that means to reduce these losses only. See, you cannot avoid, but you can reduce the losses, right? So you try to correlate these formulas, so you will understand that how uh, 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 mathematically you can understand these things, right? So maybe in the ETAP itself we will try to understand. There you can visualize more, right? I'll explain that. Second, you have to consider voltage. See, the moment you consider voltage, you need to think with respect to the system insulation. System insulation. What do you mean by system insulation? So maybe like when you put 220 kV, that means they have to put lot of insulation. Or what do you mean by insulation? Insulation is nothing but it could be a air insulation. The conductor around air that acts as the insulation, or between the conductor you have to give some clearances, right? So that is insulation, right? So maybe your voltage, what is the voltage you are putting in, that decides equipment insulation, or the basic insulation level of the equipment. Everything it will be decided based on the voltage only, your system voltage only, right? So this is very important. And current impacts the conductor cross sectional or thermal ability of that the conductor. Your system voltage impacts the insulation of the system.